In this video, you're going to learn how to apply different properties involving exponents. Before we could jump into these properties, it's important that you understand some language or some vocabulary words. So those two vocabulary words being the base and the exponent. So when you have a problem containing an exponent, the letter or the number that contains the exponent is called the base. Where the little number or letter, but this year it'll be numbers, that's raised up a little bit, that is called the exponent. So again, it can be a number, it can be a letter. In this case, the 4, because it has the exponent of 7, is called the base. And that is really, really important to understand. So what's the meaning of 4 to the 7th? You've done this several times. The exponent tells us how many times to write the base. So this exponent here of 7 says write the base of 4 down 7 times. And we would multiply and get whatever we get. But you quickly now see something brand new that you've never seen before. And that's, what if you have a negative exponent? What that negative exponent tells us to do is to flip the expression. So whatever is in the numerator will now become a denominator. So this 4 to the negative 7 is just 1 over 4 to the positive 7. I would flip the base. Now, being the base is 4, or 4 over 1 to the negative 7th, the negative tells me to flip the base, and then I would go to the positive exponent and get whatever we get for 4 to the 7th. So 5 to the 3rd, 5 is the base, 3 is the exponent, and we know that that's just 5 times 5 times 5. But 5 to the negative 3rd is we take the base, which is 5 over 1, and we would flip that. So it's 1 over 5 times 1 over 5 times 1 over 5 to get 1 over 125. Now, when we are multiplying expressions with the same bases, that is important. They got to have the same base in order to do this. The rule is to add the exponents. So the shortcut rule, which you're going to want to know, is the bases are the same. They're both 5, so I bring that base over. And the new exponent on the answer will take these two exponents and simply add them. But why does that work? Well, 5 to the 3rd is 5 times 5 times 5, and 5 to the 2nd is 5 times 5. Altogether, I have the common base of 5, and how many times did I write it out? 5 times. So again, the rule is to add those exponents when the bases are the same. Whether the bases are numbers or whether the bases are letters, they gotta be the same in order to do that. When we divide expressions with the same bases again, this time we're going to subtract the exponents. So you notice that the bases of 4 are the same, so I'm going to bring that down. And what I do with these exponents is we subtract them. 5 minus 3 is to the 2nd. I could go further and say that 16, or I could just leave it for the practice of the rules, which is the new stuff, just 4 to the 2nd. So let's show, why is this rule subtracting? When we were multiplying, we add the exponents. When we're dividing, we subtract the exponents. Let's show how this works. 4 to the 5th is writing the number base of 4 down 5 times. That's what that meaning of 4 to the 5th is. And 4 to the 3rd on the bottom is the base is 4, and we would write that 3 times. From there, I just start crossing off. 4 cancels with a 4, 4 cancels with a 4, 4 cancels with a 4, And what I'm left on top is 2 4s, so 4 to the second, and just a 1 on the bottom, which gives you that 16 like we got before. So again, when we are multiplying and these bases are the same, we add. And when we're dividing with the same bases, whether they're numbers or letters, we subtract the exponents. Now our next rule is, what if we have something called a power to a power, which means an exponent to an exponent. Technically, I have just one expression, and that's 3 to the second. So I don't need to worry about if the bases are the same or not. But what's important to look here, what's different from this than the previous examples, is here we had the base written twice, same base. Here we had the base written twice. Here we have just one single expression, but we have two exponents. And this is often called a power to a power, an exponent to another exponent. And what we do for this when we have an exponent to an exponent is we multiply the exponents. I don't have the base written twice. The base only has to be there one time. But when you have a power to a power, you multiply. So this would be 3, 2 times 3 is 6. And let's show how that works. This 3 on the outside means take whatever in the inside and write it down 3 times. Now, from our rule up there, we can add those exponents. 2 plus 2 plus 2 is 6. Or we could break these down even further. 3 to the second is 3 times 3, 3 times 3, 3 times 3. And how many 3's do I have? 1, 2, 3, 4, 5, and 6. Please do not get this confused with this, 3 to the second times 3 to the third. In this particular example, you would add these exponents because the base is written 2 times, and we are multiplying. This does not equal this. Again, the big difference is here we have the base written twice, where here we just have a single base. So those are the 3 rules. Multiply. When you multiply your exponents, when you have a power to a power. When you're multiplying with the same base, you add exponents. And when you're dividing with the same base, you subtract exponents. Now this is a little bit different because we have 9x to the third. I don't have a base written twice. But my first question for you is, what is the base? And hopefully you're saying, in this case, it's a 9 and an x, because the whole thing is getting an exponent. If I had 9x to the third, then the only base here would be an x. But the minute I include that in parentheses, now your base is the full thing because it's inside parentheses. So what we do for this is we're going to do both parts get the exponent. 9 will get the exponent, and so will x get the exponent. And 9 to the third, 9 to the third will be 729. X to the third. Now, why does this work? Well, this 3 tells me this is my whole base, and I'm going to write it 3 times. 9 times 9 times 9 is 729. X to the first, x to the first, x to the first. When I add those exponents, is x to the third. If I had this problem over here, 9 to the third to, well, let me change that, sorry, 9 to the first to the third, it would just be 9 to the third. I would multiply those exponents. The 9 is the base here. So the base is just carried on through. Okay, when we are dividing a quotient with an exponent, notice the 3/4 are both in parentheses. The exponent applies to both of them. So it would be 3 to the third and 4 to the third. 3 to the third is 27, and 4 to the third is 64. Now my question for you to ponder is, why couldn't I subtract my exponents? Why not subtract? We've been talking about the rules. So here's my questions. Why not subtract the exponents and get 0? Your answer is because you have different bases. In order to add or subtract your exponents, these bases here and here have to be the same. So why does this work? Well, 3 to the fourth, 3/4 to the third is going to get written 3 times. Because the base getting the exponent is 3/4. And that's where your 27 over 64 comes in. Take a moment to pause this video, and I want you to try numbers 1 through 4. And then I will go through and explain it. Hopefully you paused this and you tried them on your own. Number 1, notice the bases are the same of 7, so I could apply a rule. Bring the base on down, and the rule would be to add the exponents because the bases are the same and we're multiplying. Could I put, because 6 plus -4 is 2, could I put 49 if I wanted to? Yes, you could. Number 2, the bases are the same of 3. So what I'm going to do is subtract my exponents and get a -5. But I'm not going to leave that because we learned in the beginning of this lesson that a negative exponent, this negative tells me to flip. This negative is going to tell me to flip that base. So it's going to be 1 over 3 to the 5th. And then we learned the rule, this 5 applies to both parts, 1 to the 5th and 3 to the 5th. So 1 to the 5th, 1 to anything is easy, is just 1. And 3 to the 5th, if I do it quickly here, 81 times 3 is 243. In number 3, you needed to multiply these exponents. I have just one base, and that's my 2. It's not written down twice. So I'm going to multiply these exponents. I get 2 to the -6. And again, the meaning of this negative is to take that base and flip it. So it'll be 1 over 2 to the +6. And this 6 applies to both, so it'll be 1 to the 6 and 2 to the 6. 1 to any power is going to be 1, and 2 to the 6th power is 64. And number 4, this negative here is telling me take my base here and flip it. So this becomes 5 over 2 to the 3rd. So to go from one step to the next, all I did is I used the rule for that negative exponent. But now it's a positive. So this 5 to the over 2 to the 3rd, that 3 goes to both. 5 to the 3rd, 2 to the 3rd. 5 to the 3rd is 125, and 2 to the 3rd is 8. Important to know your rules, so then you could apply it all the way out. Okay, your homework and you could work on right now is page 77 and 78.